So the number one killer of people under 40 in America is automobile accidents. So I figured let's train him on that one. So he's got a little go-kart that he learns on, but I've gotten him now an Xbox with F1 2019 on it and Forza Horizon 4. For those of you who are not aware of what this looks like when you put somebody in front of a screen, dadgum if it doesn't look exactly like real life. And we have a steering wheel and all that kind of stuff. I've tried to set it up, make it easy for him, and within 2 days was watching him outperform me. He's 6 years old. So my ego, which I try to manage, has taken such a significant blow now that if you could look for some signs of clinical depression in me, that would be helpful, and reach out if you see them happening. But I'm getting crushed by my 6-year-old son and something that I'm teaching him how to do. All right, yes, sir.
Can I come play with that?
Please. It's the gaming system's slightly larger than the vehicle you operate on a daily basis. So Dennis drives a smart car and has, by the way, is equipped with all the cool comebacks. So sometime try your little smart car insult out on him, and he's got a good jiu-jitsu turnaround for basically anything you can give him. He can actually park that thing nose in on a parallel parking spot, and has done it a couple times, and the cops have been like, it doesn't look right, but I don't know what to cite you for. Dennis is like, that's right, I'll see you later.
Scott, it doesn't have parking ticket avoidance though. It won't move itself.
No, it won't. That's the last thing it needs. That's right.
Not that smart.
It's getting there. Maybe one day. Okay. Let's step into our topic for today. We've talked a little bit about, we're continuing, our overarching arc here is we're trying to make the case from zero for God, and then ultimately for Christianity. So we're just making the case for a general theistic case right now, and the argument that I've been trying to put forth is not the theist has something to prove. What I'm really saying is if one takes a good hard look at all the data in the way that everybody agrees, or at least we all agree, and it seems like the rest of the world agrees, is the right way to look at things. That is to say, use logic and reason, and use good scientific empirical evidence. If you use those two things, and nothing else basically, that those are the go-to things that you use, and you apply them against the data that we come up with, and against the philosophical points that seem to be the most coherent, that what turns out to be the case is that theism is so overwhelmingly probable that ought to be, after you look at the evidence, the default position. That ought to be the position of the greatest strength, and it would take an enormous amount of evidence to overcome the evidence and arguments that already exist on behalf of theism. That's the point I'm trying to make. It's very much counter to what we kind of hear popularly today, which is, no, the good rigorous philosophical thinking comes out of the secular world, and these religious folks are, kind of casting into the wind a little bit, and really having to have an uphill fight to prove that something like God would be a realistic conclusion to come to. I'm saying that that's not the case. And so we've looked at a couple of arguments, and we're going to add what I consider to be the argument that is either equally or most scientifically based. And what we're talking about here is an argument that is a probabilistic argument. And so this argument is going to say something like this. Our universe, that is to say, when we say our universe, we mean everything that's physical, material, universe, everything that is material, that is to say time, space, matter, and energy, everything that we see in this physical world, our universe exists the way that it is due to either one of these three things. So why, and what we're trying to do is say it must be one of these three things. There are no other choices. So this is an A or B thing that we're going to say. It is either A or it's B. What we're going to say is it's either A, B, or C. Now if there was a D or if there was an E, then this argument would not hold. But we're going to use the A, B, and C here because nobody else has ever come up with a D or an E. It may be that there is a D or an E, but we just don't, we've been thinking about it for thousands of years and we can't come up with anything else. So it either is due either to chance, that is, things are the way that they are out of sheer chance, necessity, and remember what necessity means. means is it has to be the way that we see it. It couldn't possibly have been any other way. Or design. Okay, so this is the A, B, or C. Our universe looks the way that it does for one of three reasons. Either it happened by chance, either it had to be this way and it couldn't have been any other way, or it's this way because it was designed this way. Now, if anybody can think of a 4 or 5 or whatever, let us know, and actually secretly let me know, and we'll go publish a paper or something like that. No, just kidding. Nobody has thought of anything else, so we're sticking to these 3 for now. Okay. Now, this is usually not a controversial premise. Everybody says, yeah, okay, fine, I get it. That's one. Then we say, as the universe is or does not exist, due to basically 1 or 2, and then 3 is going to say, therefore, universe exists the way that it does, and we'll put another word on it in a second, due to design. And of course, if it is design that is the reason for what we see, then it implies a designer. So it doesn't prove the Jewish God, the Christian God, the Islamic God, any Hindu. All it does is say there would be a designer behind this universe. That's it. If so.
When you say the universe, you mean the universe that we're aware of, that we can see.
Yes, that's right. Our observable universe, and in some cases implicate some. It will also allow us, as far as science can speculate, because this is going to be based on scientific evidence, as far as the science can speculate on what the rest of the observable universe would look like. On what the rest of the actual universe would look like, the unobservable universe, that would hold as well. So we can make statements about the universe that we can't see.
But there could be other universes.
If it's some sort of multiverse, then that is actually contained in the term that we're going to use here, universe. So the universe means everything. Like I said at the beginning, it's all time, space, matter, and energy. There may be portions, and what Dennis is referring to is, let's say that this is the universe that we can see. And it's something like, I forget what it is, but it's going to be something like 98 billion light years across in diameter, if it's 14 billion years old or something like that, from where we can see it right here. Remember, we can see this is where we are, either because we're at the center of a spherical universe, or because all portions of the universe look the same, no matter where you look from it. So whichever of those two it is, at least our observable size, that part of it is going to be basically a sphere, if space is flat, and space seems to be flat from what we can tell right now. Although there's always something new coming up saying maybe not. Okay, if that's the case, it may be the fact that there's more universe out there like this that we can't see, that the light from it just hasn't reached us yet. It may be the case that we're one little bubble universe in a whole bunch of bubble universes that are out there. And when we say universes, what we mean is other causally disconnected universes, with the exception of the causal connection of whatever the engine of inflation is or whatever drives these things. But the point is, what science doesn't allow is for us to turn around and say, one universe here responds to physical laws like gravity and strong force and weak force and electromagnetic force. And other universes out there are unicorns and unicorn power. So you can't do that if you're going to be scientific. If you're going to be scientific, what you have to say is, these other universes also result from the laws of physics that we observe in this universe. And that's the way it is. Surely you would say this other universe over here functions entirely on unicorn power, the magical power that unicorns bring about by their own will in instantiating reality as they wish in that particular little bubble universe.
They don't necessarily have to have the same laws of physics.
They're going to have the same laws. They're not going to have the same constants and quantities.
I don't know. Science doesn't. Nobody knows.
Nobody knows, but once you stop doing that, you're not doing physics anymore. Now you're doing something else. So if you're going to say there are laws of physics that exist that we can just make up, that they're not ones that we observe, you're not doing science anymore. Now that's fiction. That's just making stuff up. So remember, science turns around and says, I see things behaving a certain way. We make testable predictions about them. We test our predictions in such a way that we say, okay, these are laws that these things are following. Those laws that we've discovered here, there may be more laws, there may be laws in this universe that we don't understand or we haven't discovered yet. If so, okay, those laws are also the ones that we're talking about when we're talking about other universes under the regime of, according to the physics that we see, this is the way the universe could be.
But these other bubble universes they don't necessarily have to have the same laws of physics we do.
Yes, they're going to have the same laws of physics if we're going to make predictions about them that we're making based on physics.
I don't know how you can say that.
I just said it that way.
You said it. I just,
If we're going to base our predictions on the laws of physics, we have to know what the laws of physics are in order to make the predictions.
that doesn't mean that these other bubble universes are going to have the same, just because we want to make predictions about them doesn't.
I know, but now what we're talking about, if you do that, if they say there's another law of physics that you don't know about, and that's that unicorns can do anything they want with their unicorn horns, and they can make things by thinking, and the horn instantiates that reality. That you can do that, but you just recognize that you're making that up, and that's a law of physics that we don't think is true, or we don't know to be the case.
You just don't have any reason to say that. If you can gain some information on what they might look like, or even if they exist, then you could say, all right, we're going to use that. But otherwise, it's just hand waving. We have no idea.
We have no idea.
Right. So if again it's science, either say, well, if we have no idea, let's not deal with them at all, or let's at least assume that they are consistent with what we know.
I don't know how you can make that assumption. If you acknowledge that we don't know, we don't know.
Well, let's go to this point, and then I'll answer that one. I'll make another stab at it.
How does this bubble universe theory differ from the multiverse?
Multiverse should be, when properly used, multiverse is a term that means multiple regions of the same universe. Now that same universe, bubble universes basically came into existence for a couple of reasons, but forget why they came into. The engine that drives them typically is thought to be inflation. So whatever this inflationary force, sometimes thought to be dark energy, sometimes maybe something we don't understand, but whatever it was that caused inflation, for inflation-dependent models, not all models of the Big Bang or indeed of the universe at all, are inflationary models. That just happens to be kind of the one that's holding the most sway right now. There have been some recent challenges within the last year to these inflationary cosmologies. But if you're sticking with inflationary cosmologies, because this one seems to basically be able to run at different rates, then what may be the case is there's some, they tend to model these things in phase space. Phase space is not supposed to represent actual three-dimensional space, but it's a space of these possibilities. So in these phase spaces, it may be that these bubble universes expand extremely rapidly, and they'll never come in contact with each other. It may be they do come in contact with each other. So some of these brain cosmologies are looking for possible interactions where bubble universes are expanding and touching each other at the edges. And some people have argued, hey, some of what we've seen on these Wilkinson, Michelson, and COBE and these probes could be considered evidence of brain worlds, brain universes intersecting each other. So they're basically areas of reality that are expanding like our universe is expanding, but that they're not causally connected in that they interact physically now. So they're causally, if you wind them all back, they are causally connected. But right now they're completely causally separate zones in the way that we have at least causally separate zones right now. Like if you look at the other side of the universe and you say, I can see this galaxy on the other side of the universe. I want to go to that galaxy. You can't actually get there. There are regions of space that you can't travel to because you can't go faster than the speed of light. And the expansion of the universe, if our model understanding is right, they're expanding away faster from us now than the speed of light is. So they were causally connected at one point. They're no longer causally connected because of the expansion of space.
So to clear things up, because there's another thing that gets thrown around as the multiverse, and that's the thought that there's an infinite number of decision branches at the quantum level, right? For interaction of particles that are all going on simultaneously in different, it's the same universe, copied, right?
Yes,
gajillion different times.
Yes, and it forks and branches every time.
Forks and branches. But the problem there is like there's no causal relationship, right? Because if everything's a possibility, then
Yeah, well, you could still you could argue causal connectivity. In fact, you would have to argue causal connectivity all the way back to an initial state there. But probably interesting to remember, a lot of people, including big name physicists and cosmologists, very irresponsibly use a few terms when they're talking about this. One of those is nothing. Another one is infinite. So if the universe has a finite age to it, which is what our best cosmology says right now, then that finite age, no matter how many decisions you add on to it, no matter how many times it forks, and the number of forks, sends that thing right through the roof. It's still finite, right, at any given time.
but
Potentially infinite, but actually finite.
right, but not giving validity to that theory, but that's still captured within what you're saying.
Yes,
Like, that
yes,
could
yes.
still be like that would just be
Yeah, in fact, to make this even easier, what we can say is our universe, or we can say the multiverse. So these are, in this context, these are the same thing. Our universe and the multiverse are the same thing. Okay, so we can talk about what we can see in our observable universe, but the statements we're making are statements about the multiverse as well. Okay, I'll try one more stab at Dennis's point. Dennis, maybe I can say it this way. The multiverse that we see in our universe are finely tuned according to the laws of physics, the known laws of physics, either because of chance, necessity, or design. The universe that we currently see and its laws of physics do not exist due to one or two. Therefore, the universe as we currently see in its laws of physics exists due to design. So what we're saying is there's a caveat on all this, which is we understand enough about the laws of physics to make these kinds of statements. If you want to say, well, we just don't know, then you're just done doing the project of science. Because the project of science turns around and says, I'm going to make hypotheses, I'm going to make observations, I'm going to make observations, I'm going to hypothesize, I'm going to design my test, and then I'm going to interpret its results. And then I'm going to feed that back into this loop.
I'm saying it's all right to say that science doesn't know certain things.
Sure, but that's a metaphysical statement.
The more it knows it knows less than it thinks it knows.
But that's a very potent metaphysical statement, not a scientific statement, right?
I hate that word, metaphysics.
It may be, but meta just means not physics. It means above physics, another layer. And if what you're going to say is, I'm evaluating physics, and physics is saying certain things, and I don't think physics is potentially right about this, or physics isn't all that there is, by definition, you are now doing metaphysics.
All I'm saying is that we don't know as much as we think we know about even our universe, much less all the other universes that could be out there.
Sure, but let's say we're scientists and we're doing our experiment, and we do the experiment and we say, okay, I'm going to do this experiment based on the laws of physics I know, right? When an astrophysicist looks through their telescope, they don't turn around and say, wow, I see this flashing light up there, and it seems to be coming from this heavy source that's like a star size, and so maybe it's a beam coming out of the star and spinning around really fast, and I'm just seeing it once in a while. Or, you know what, maybe it's a unicorn flashing their light on and off. Technically, it could be either one, right? But nobody turns around and says, what they do is they deal with the stuff that we know exists, or we think exists. We don't deal with the stuff we don't think exists. You don't even put that in the paper, right? You don't put in the paper, hey, this could be an alien Aldous lamp, right? Most of the time you just keep that out of it, and you say, based on what I see, I presume that this is some kind of spinning, heavily dense former star type of thing.
It keeps coming up with new discoveries like dark energy, dark matter. And you go, wow, what is this? They have no idea what.
Well, those aren't actually discoveries. Those are still theories. There's
Yeah.
still people who don't.
Well, there's something out there they call dark
Still
matter,
people who
and
don't
they
believe
call
all
dark
of it.
energy. Something exists that we have no clue.
Yeah, but Dennis, the whole point is the reason that they think dark matter exists, the reason that they think dark matter exists is because what they see is behavior out of certain astronomical systems that is inexplicable given the laws of gravity.
Yeah. Well, there are no laws of gravity.
What?
All right, well, if we're going to take that position, sir, then we can't even discuss things.
Well, what I mean by that is you got quantum gravity, you got relativistic gravity.
Those are theories of gravity, of what
Theories.
causes gravity. We have laws of gravity. It's fairly well established. It's general relativity. And Newtonian like Newton's equation is the one that we use all the time. We use the law of gravity is basically the most certain law that we've got.
All that measures is the force of gravity. It doesn't explain what it is.
That's what a law is. That's what a physics law is. It doesn't say why. It's a descriptor.
So what is gravity?
But gravity is an attractive force between two bodies of mass and or potentially energy densities as well.
Not at the quantum level.
Well, if we want to have the quantum physics discussion, fine, but you can't seriously be saying that there's no law of gravity that we know. Every bit of science that we're talking about in cosmology is based in the idea that there's a law of gravity that we can see. All of the stuff about dark matter comes from the law of gravity. Gravity attracts with a certain force. We see this galaxy spinning in such a way and rotating in such a way that we can't explain it if there's not some other matter that we can't see there, therefore there must be dark matter. The inference that dark matter exists because we believe in the law of gravity.
Quantum mechanics and general relativity can't be combined because of gravity.
That's irrelevant to this discussion of whether there are laws of physics. You have to have laws of quantum mechanics and you have to have laws of general relativity in order for them not to fit.
But they don't fit.
That's true, but that doesn't mean they're not laws. They don't fit because there are laws.
They have their theories.
All right. Okay. We'll go on.
Okay.
No, I think that's an important point, Scott. The reason, just so my science card just doesn't get revoked. What I meant by the dark energy theory was when there was no theory about why something like that existed, they didn't know why this thing, this anomaly was happening. They gave it a name. They didn't just say, I don't know what it is, therefore I'm going to pretend that nothing is wrong. They said, there's this thing we don't understand. So they stitched the boundary of it, and they said, this is, I don't know what they called it before they called it dark energy, but they called it something else. And then they said, oh, well, then it's this. And then, well, if there's energy, there's matter, and then therefore, and then that theory got fleshed out over time, and then they do experiments for it. But even when they didn't know what it was, they gave it a name.
If they give it a name, but the name doesn't.
It does, because the boundary of that unknown is still it's a known unknown, right? Because they know the edge of it. It's not infinitely possible, right? There is a set things of which it
Yeah, I think maybe more simply put, it's sort of like this. I see a bunch of stars in a galaxy. Given everything that I can see, I can now fill in, somebody correct me when I get this wrong, but here's the law, Dennis.
Hey, I remember that one. I used it like 3 weeks ago.
All right, good. Hopefully it's something like right. But if you use something like this and you don't do the general relativity thing yet, just for simplicity's sake, and you say, given how much of these M's that I see, this mass, these masses that are working together, I'm going to treat the galaxy like it's a point mass, and it's going to have so much, and it's going to vary at these different radii, and so you need a more complex version of this, but it basically reduces to the same thing. That the universe, this rotating galaxy would not behave the way that we see that it behaves. If it had more mass in it, specifically concentrated in some of these, actually a fairly predictable density gradient, if it had mass in there, then this stuff that we can't see, then it would hold together like that. So that leads us to believe that since we know this to be true, then there must be dark matter or something like it holding together. I turn to my local astrophysicist to say whether that's even close to roughly correct. And if that's right, then the prediction happened because we believe that we have a law of gravity. If you didn't have a law of gravity, there would be no reason to believe there was dark matter.
I object to the use of the term law.
Okay, well, Dennis, all I can say to you on that one is you're going to have to go back out of class for this one and ask anybody in the scientific community whether such a thing as a law exists. But look in any textbook, from grade school up to PhD, there are laws of physics. Laws of physics exist. So you're just mistaken about that. Okay, so if we're going to say something like we're just talking about the laws of physics that we know or are even speculating about, that we're going to say, are they due to chance, necessity, or design? Does anybody want to discuss necessity?
Yeah, that's what I was going to ask.
All right,
is,
go ahead.
How do we know the second part of this argument without getting us bogged down? If you're not want to go there, that's cool. Because I don't need to argue it. But how do we know that the universe does not exist due to chance or necessity?
It depends on whether we think that it's reasonable or the case that it could have been different than it is. And what we mean by different than it is like I might not exist in the universe, or I might have chosen something different for breakfast.
Yeah, and I sort of go with Dennis a little bit on this one in the sense that I don't know how we could potentially even say that we know that. There's no way for us to be able to test that. There's no way for us to be able to say for certain that that's
So
the case.
in philosophy, typically the way that we test ideas, in science, we have a way to test ideas, right? I'm going to say this physical thing, if I do this physical thing, then that physical thing might result. I do this physical thing, and then I see whether I was right or wrong. In philosophy, usually the best thing we can do is say, does this concept match with, is it internally consistent, A? Secondly, does it match with other things I know to be true? And in asking whether it's internally consistent, or the things that I say I believe are true, in asking whether it's internally consistent is it self-contradictory? Does it make sense? Is it even a concept you can have? So one of the reasons people think that necessarily there's no such thing as a square circle is try to conceive of a square circle. What does a square circle, what does that concept even mean? And the idea is it doesn't matter how much you grapple with it, you'll never be able to articulate this is what a square circle is. You either end up with a square, or you end up with a circle, or you end up with something that's neither, but you also wouldn't call a square circle because these definitions preclude each other from being put together. They don't fit. So the reason that we say that it's not due to necessity is we say, it seems fairly easy for me to conceive of a universe that's half the size of this universe, or 99% the size of this universe, or expanded slightly less quickly than this one did. Or the law of gravity is just maybe, what if the gravitational force here, where the G that I threw up there, the value for G, which I don't remember off the top of my head. Does anybody, do you remember it?
It's 6.67 times 10 to the 11 newtons times meter squared per.
Okay, so let's say it's 6.665 instead of 6.670. I don't know if he included the last significant digit or not. But if so, can you imagine that that's the case? Yeah, conceptually it makes a sense that it's maybe gravity could be slightly stronger than it is now. So since we think that that's the case, which by the way is what physicists think, but one of the reasons that there's a lot of this fine-tuning discussion is physicists are like, nothing that locks the law of gravity down to being exactly that constant. It could be a different constant for all we know. Okay, so that's the reason that we say necessity. Everybody kind of throws out necessity as like, well, looks like it could be different to us. So yes. Now the question is basically down, or is it chance or is it design? And what the designer is going to say is something like this. We have an awful lot of complexity in this universe, including sentient beings. And when you see stuff that is highly complex and interworking, that the kind of stuff that we find that looks like that tends to have a designer, at least on the human side. And stuff that that doesn't could be random, could be chance based. Now maybe it's all chance based, so we'll acknowledge that. But when you see a lot of complexity, our intuition is to attribute design to it. Now maybe that's just a problem with our own brains. Maybe that's some kind of evolutionary deal that's going on, right? But when we do our science, we do this too, right? When we show up, or I like to say everything I ever need to know I learned by watching The Hunt for Red October. You remember Jonesy is sitting there and he's trying to explain to the captain very excitedly how he thinks he's found this submarine. And he says, hey, I'm sitting here and I'm listening to this when the propellers went silent. And here's this whoom sound that kind of looks, it's this wave that sounds like that almost to you. And he says, he starts to talk about how the software in here was this algorithmic processing software that was originally used to look for seismic events. And so when he says, when I asked the computer, it said magma displacement. Well, the magma displacement, some sort of geological event, is going to have a random pattern to it. That's basically the assumption there. And then the captain says, I'm not following you, Jonesy. And he says, hey, sorry, sir, listen to this at 10 times speed. And he runs it up and he gets this, I'm not gonna make it a square wave, but he gets this knocking sound. It goes knock, 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 knock. And he says, now that's gotta be man-made. So what Jones did, what The Hunt for Red October says is, when I hear a certain signal, because natural signals that are random look a certain way, And signals that are made by a designer look a different way. The question is, do we detect those kinds of signals and patterns in nature? So that's really what the designer's side of this argument is going to say. The chance side of this argument is saying, no, in fact, everything that we see here is potentially predictable based on chance alone. It's something that could have happened, and maybe, if we're saying chance, might be likely happened due to chance. So the designer is really going to try to say it's not necessity. If I can show that this chance right here is very, very small, is less than or equal to 1 over some huge number, then what we'll say is it's probably not due to chance. Now this argument will never be able to say it can't be chance. All it can say is it's probably not chance. If it's probably not chance and it's not necessity, then what's the probability that it's designed? Now we've got to ask that probability statement too. Yes.
So I don't want to take us down a rabbit hole either, but like I have a really hard time. I mean, on the face of it, I gravitate towards design, right? But if we're being intellectually honest, like you're asking us to do, and like wire brushing this, right?
Yes, right.
So that denominator right there, like, where do we get that denominator? Knowing that like sensitive dependence on initial conditions and chaos theory and all that other stuff, right? Like, what's to say that another universe couldn't have started by chance, ended up very much, you know what I mean? Like, I've heard the argument before that, like, the way DNA is constructed, it's astronomically impossible that this couldn't happen because, just from chance and stuff, which
yes.
I'm inclined to believe that intuitively,
right.
But scientifically, where do we derive a denominator that makes that the case?
That's a very good question. Now here's how we do it. All right, we're going to pick up a deck of 52 cards. Okay, here's our card deck right here. And we know that there are 52 of them in there. And we know, or we're going to say that we think there are 52 of them in there, right? Even when we make speculations about all this stuff, we basically have to ask the question, is this a full deck of cards? Yes, it is a full deck of cards. All right, anybody monkeyed with it? No. As far as we know, there are 52 cards in there. So it's always going to be as far as we know. As far as we know, there are 52 cards in this deck.
Some people would ask if you have a full deck.
The answer to that one is fairly clear. We won't speculate on that here. So in what is a complete deck, we know there are 52 cards. We know there are 4 suits. We know they number from 2 to 10 and then jack to king. Ace, whatever, however you put it. Obviously not a card player. In this card, what we can say is this. Given that there are 52 choices, and each one of those cards is different, if I pick one card at random, what's the probability that I pick the ace of spades? It's simply 1 over 52. So that's as mathy as it has to get here. That's as hard as it's going to be. Given I've got 52 unique values, if I pick one at random, it should be 1 in 52. Now, there's a whole problem with random, right? Computer-wise, there's no such thing as random because you have to program the computer. Pseudo-random, or even if it turns around and takes some sort of random, something like typing on a keyboard, the frequency of typing on a keyboard, which is a random part of some random number generators, take that as an input to then throw in there to generate pseudo-random effects. That still is also not random. That's dependent on a computer operator. And if it turns out that computer operator has some sort of pattern to which they're typing now, it's not random, is it? And arguably we do have that kind of thing. Okay, so if this is all we're doing is saying it's number of choices, number of tries is really what it is. How many tries over total possibilities. That's all we're doing when we're doing this. So let's just pick one. I'm going to pick one of the biggest numbers out there. And we'll talk a little bit about the size of this number. But that's what we're going to say. So by the way, if someone says, I drew an ace of spades on my first try, someone says, I want you to pick the ace of spades. And you go spread out the deck and you pick it up and you're like, oh, ace of spades. Everybody, you'd be like, well, I guess that could possibly happen, right? That can happen. Now, if you put a $50 bet down on it, and you're like, you spread it all out, and someone's like, this is a non-cheating deck, right? I can shuffle it or whatever. You lay it all out, and they're like, all right, I bet you $50 you can't randomly pick out the ace of spades. And you're like, oh, ace of spades. The first question is like, hang on, wait a second. How do I know that I just didn't lose $50 to a trick? Why? Imagine the same thing. I'll bet you $50 that it comes up that it comes up heads for flipping a coin. And you flip it and you're like, ding, 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 heads. You lose your $50, but you're not like, hang on a second, you're probably cheating here. That was 50-50. That was your bet. Your bet here was 1 to 52. So you're going to be a little bit more amped if someone wins on the first try in the random card pick thing. If instead there were, how many possibilities are in what's the order of magnitude of some of these Powerball kind of things? I don't even know, but let's say that,
Something like that.
say again?
Like 2 million.
Yeah, let's say it's one, looks like, or let's say 1 over 10 to the 7th or something like that, or 1 over 10 to the 8th. Let's say that's the probability. So 10, 1, 2, 3, 4, 5, 6, 7, 8 zeros, something like that. So 1 in 100 million, or 1 in 10 million of 10 to the 7th. If someone comes in, they're like, I'm going to randomly pick the number, and they walk up and to the Powerball thing, and they're like, it's going to be these set of numbers, and the person pulls them out, and it's exactly that on the first try. We tend to turn around and say, hang on a second, are you sure? Now, people win the lottery all the time. Now, why do people win the lottery all the time?
Because a lot of people play the lottery.
This number is not 1. This number is not 1. That's the right reason. What happens is, it's 1 times 10 to the 8th. Let's say it is 10 million. How many people play? You know, by the time 2 million people play this lottery, you can see that when you kind of knock these off, and this is not exactly how the probability works, but if you knock this off, you're closer to something like 20% chance that somebody's going to have won here. That's not exactly how it works, but you get the idea, right? Right. So, you're right. Exactly, and a bunch of other things too. And the process, we're assuming a lot about the process by which this happens too. Okay, so this is the reason, if it was just one shot and someone walked up and predicted them all, you'd instantly accuse them for cheating, right? Instant investigation. 2 million people play the Powerball and somebody wins. We're not necessarily thinking anybody cheated, because now we're like, reasonably speaking, 1 in 5 chance of this happening, 1 in 20 chance of this happening. That's not completely insane. Let's assume they're probably legit. Okay. There are something like 36 different constants and quantities that are factored into the physical laws of our universe, like the law of gravity. G is one of those types of constant. There is an initial set of conditions that talks about the level of organization of the universe initially. That is to say, to get the universe that you see here, and by that I mean like having heavier elements like carbon, like uranium, like any of the stuff that you see that's not hydrogen and helium and lithium and beryllium and those kinds of things. Anything other than these very light elements, or really anything other than helium and hydrogen, you have to have some fairly fine tuning. Just forgetting all that for a second and just saying the level of organization of the energy itself, of all the energy that was there in the initial portion of the Big Bang, in a Big Bang cosmology, how organized does it have to be? How organized does it have to be? And when it's disorganized, we say it has high entropy. And the energy and the universe is always going to higher and higher in entropy. Entropy is always increasing. If you kind of wound the clock backwards, and entropy is getting lower. That is to say, it's getting more organized. You can imagine like pouring, let's say you had a very highly organized set of oil molecules in a little dish. So they're all right next to each other, whatever else. And you pour them in water, and they spread out, and they get interspersed with other particles, and their level of organization is less than it was initially. It was more organized, it was more contained, now it's less. Or something like that, or maybe a shelf of books. You know, over time, if you mess around with the shelf, the things kind of fall apart. How organized were the books originally on the shelf? These are kind of measures of organization, imperfect ones, but measures of organization. How organized did the universe have to be? Now, this is Sir Roger Penrose's number, but it has stood for a while. As far as I know, it's considered sufficiently authoritative that it's a number people deal with. The level of the number of possibilities of how organized that thing could be, and that takes into it a lot of different factors, but how organized it could be is 1 part in 10 to the 10 to the 123rd power. That's just the initial entropy condition, is that there are that many possibilities of what that entropy condition could be, and the one that we have right here is the one that allows a universe of this type, a range of universes of this type to exist. Another person has put it in a way of like, I think I said it last time, if you imagine a cube of water, like an ocean of water, that's 1,000 miles wide and 1,000 miles deep, that these are all possible ways the universe could be, the initial entropy condition could be, that a oil spot, the thickness of a leaf and the size of a leaf floating on the surface would be the range that allows for universes like ours. And what we mean by like ours are universes that last kind of as long, for a length of time, like billions of years, and that allow for heavy elements like the elements that we have in our periodic table. That's how infrequent it would be. Now, to give you an idea of this number right here, there's a number that you'll hear that you search on every day called a googol. A googol is 10 to the 100 power, which means just 10 with 100 zeros after it. So we write 100 zeros, and ultimately, if we keep going, we get a googol. Someone tried to come up with one of the biggest numbers they could think of, and this one held, I think, for a while until Graham's number came out, and maybe there's one bigger than Graham's number now, but at least the highest number we think we can get to. When you do 10 to the 10 to the 100th power, so 10 to the googol, you get what's called a googolplex. So googolplex now means two things. Google's headquarters is now called googolplex. But this number is called the googolplex because someone was just basically trying to say, let's think of how big a number we can think. I mean, 1 minute to work through this number, and we'll come to you first.
Hold on.
Yeah.
What do you mean the biggest number that someone can think of? Can't I just put another exponent on there and it's bigger?
Absolutely, right. And
It
so,
doesn't matter.
so we're trying to talk about numbers that we can kind of conceive of. Now, obviously, there's no largest number, right? We get it. But in the interest of time, let me point you to Graham's number. So look up Graham's number online. At least see what that is that they're trying to say. It is not the largest number. But what they're trying to say is like, this is the biggest that we can even somehow conceive of. And of course, you can always do, kids have great intuitions, right? What do you say when you're like, I'm a better than you infinity? What does the other kids say?
Infinity plus 1.
Infinity plus 1, that's right. As far as I'm concerned, but this goes back to number theory, I think numbers are just counting. And if numbers are just counting, you can always count one more.
You know who you have to have that conversation.
I've already had that conversation,
I know.
and he hasn't commented on my paper, on our back and forth in 4 months. So you get on him about that.
So another way to look at the size of this, though, is to consider just the number of...
Yes, but let me finish. I'm almost done, and then him and then you.
Yeah.
Okay. Here's how big this number is. If you wanted to, in the same way, 10 to the 100, right? This right here is the same as this if I kept writing out 100 zeros. Okay, so the number, this is shorthand for the number. This is actually writing the number. If you want to write this number, and you took every particle in the universe, every proton, every neutron, and every electron, and you lined them up, and you wrote on the first one a 1, and you wrote on all the rest of them zeros, you would not have written this number. Think about that for a second. You wouldn't have written the number. That's just the number, okay? You would not have written the number. That's how improbable the initial, that is 23 orders of way less than 23 orders of magnitude, 10 to the 23 orders of magnitude less than the number that Penrose said captures the initial entropy condition of this universe. Now, what I point you to is this. 50% probability, you don't mind losing your bet. 1 to 52, you're probably accusing the guy of cheating, or he better be able to pull it off again. Someone wins the lottery, 10 to the 6th or 10 to the 7th. Someone wins the lottery by just walking up and picking the numbers out of one chance the whole time. You're investigating them. And you're probably charging them until you can figure out what's going on because they just stole, $300 million. Do you see this number right here? Without talking about any of the other 35, with just this one alone, what you ought to say is the idea that this universe, the kind of universe, and when I say this universe, I don't mean this exact one. I mean a universe where you get this kind of matter, where it can last this long, where something like evolution could occur. That's one of the numbers. It's the biggest number, but it's one of the numbers. And so what you ought to say is chance is a little sketchy as an explanation. That's all this argument says. All right, 1, 2, 3.
All right.
And 4.
You've got me sold on the big denominator.
Okay.
So how do we know it's 1? in as far as, right?
All right, so pause.
Okay.
How do we know it's one? Let me point out to you how I know that the kind of quote unquote opposing view here recognizes that fact. The existence of the multiverse. What the multiverse is someone says, the cosmologist looks at this number and is like, yep, that doesn't happen by chance. Like that's a poor bet. But if this number were 2, it's still a poor bet. If this number were 1 billion, it's less of a poor bet. If this number right here is infinite, if there are infinitely many universes, or there are infinitely many universe type objects in a multiverse, then not only is it not a big deal, it's like it's going to happen. Like if you have an infinite number of universes, all of which are different, then it's not a matter of like if, it's simply when.
What tells us we're the only attempt, though, I guess is my point. Like, what's to say that there weren't a huge number of...
This is why, this is metaphysics at this point.
Okay.
It's not physics. No, there is no scientific thing that says it has to be one. The scientific evidence, remember what scientific evidence is. Scientific evidence is not just thinking there could be laws. Science is saying observation, hypothesis, test, etc., loop it again. So if you're going to do that, what you have to do is say, when I turn around and say, I can't see it, but I'm going to speculate that it's out there. There's nothing wrong with that, but what you got to recognize that you're doing at that point is not physics anymore. You're looking for metaphysics.
On a scientific, physical plane, though, is there anything that says, I'm not trying to be metaphysical, right? Is there anything that says only one shot happened? Right, not speaking metaphysically, just physically. Is there anything that we've observed or can observe that says that there's not a potential?
Yeah, so we negatively test this with some frequency.
Yeah.
Of course, negative test does not mean that it doesn't exist. So what happens is the brain cosmology guys are out there and they're like, okay, if there is a multiverse and these are brain worlds, then it's possible that in higher dimensional aspects, these brains could be bouncing against each other or kind of passing through each other in a certain way that would see some sort of effects. And so if there were such things and they were sufficiently frequent, we might see these interactions. And so they looked really, really hard at some of these WMAP and COBE data and stuff like that. And they found some candidates and they were like, aha, maybe these are brains interacting. And then they run the math on it and they're like, it's inside the error bars, probably random noise, that kind of stuff. So we've tested for this, but nobody's had any confirmation of other stuff. So like on dark matter as an example, it wasn't, oh, dark matter is this mysterious unicorn power. It was like, all right, well, if there is dark matter and we have the laws of physics that we have, then it's probably, depending on what your physical theory is a little bit, you're going to see something like this. So if you've heard of WIMPs or axions or magnetic monopoles or these kinds of things, these are all physical deliverances that the laws of physics would give us if a certain other set of assumptions were true. And so we've tested for them. We went down these big mine shafts and we put these, big mine shafts and we put these big like water detectors in there, and we've stared at these things for years looking for little flashes of lights. And some people are like, I think I saw one. And they look at the equipment and they're like, nah, probably the equipment. And so we've been looking for dark matter for a very, very long time. We just haven't found it. Dark energy is even more mysterious than dark matter. Insofar as dark matter, we can at least say, if there is dark matter, it might be a particle like this. Let's go look for this particle, because this particle should interact gravitationally, but not via some other force. Or it may it may have this property of electromagnetism that other particles do not have, that kind of thing. So dark energy is more like, we don't really know what that would look like. And some people have said in the general equations of or the equations of general relativity, the omega factor, the lambda, the cosmological constant, is something Einstein put in, was like, this is a fudge factor. I'm having to, like, this is his biggest mistake. And now people are like, not such a mistake. That may be dark energy. He may actually have that in there. So, we'll keep arguing about that for a long time. But in short, yeah, we look for this all the time, and people have been speculating about it, and here's experiments that we would do to find this, and basically nobody's seen anything. As far as we know, from experimental evidence, the only universe is our universe, and the only part of it that exists is the observable universe. There may be more than that, but we have zero scientific evidence for anything more than that. It's completely speculative. Anything else out there is speculative. So if you're dealing with the evidence that you have, this is simply the evidence that we have. Yes, sir.
That's fine. I was just going to put another sense of the size of that number, but you did. So.
Okay. And I was at least adequate. Perfectly adequate. Okay.
Yes.
Okay. Back to Dennis and then Justin.
First, I have a point and then a question.
Yes, sir.
All this talk about lotteries and these big numbers, the best description I ever heard of your chances of winning the lottery are just as good whether you play or not.
Yeah, that's right.
My question is all this by way of getting up to the fine-tuning argument?
It's the design argument,
This is the fine-tuning argument.
of which the fine-tuning is part of.
Yes, that's right.
Teleological?
Teleological,
So
same
that is-
thing. Fancy word for design.
Yeah.
That's what this is all about.
This is the fine-tuning argument, slightly differently worded.
Well, there are non-God design arguments out there, but
Yes, simulation. We could be in a
Yes.
computer simulation.
so I recently had an argument with somebody who has given up on chance, and now, because he can't believe in God, he's gone to necessity. And I mean, to me, it sounds like it's basically necessity by faith, but he believes in somewhat of that there is some order in the universe, or crystalline theory, or something like that. That the reason the fine tuning is there is because the pieces just fit together that way, and it just. But to me, it sounds like just faith. I mean, right? Because he's given
Well,
up
if
something.
the pieces just fit together that way, then there's a law that describes that. If it's a law that describes that, the question we got to be asking is, so you're telling me there's a law of physics out there that's not one of the 3 or 4 or however many we want to call them now, laws of physics that we have. It's some 5th law of physics, but we just haven't detected it yet?
Right. And since all the other ones don't lean towards order, then why would this one? I don't know.
And by the way, there's no difference, and anybody who's keeping score, there's no difference between saying the planets move the way that they do because angels push them around, and there's a 5th law of physics out there that we don't know of. That's the same thing.
Yeah.
Because the angels are not nothing. The angels out there are these creatures that we can't see, which by the way is dark energy and dark matter in many cases. But at least dark energy. So something that we can't see is still having a physical effect because it's real and it behaves in this particular way. It's the same thing. So don't let anybody tell you that there's a difference between angels and a mysterious 5th law of physics that nobody can show or prove is out there. Yes, sir. Yeah, far in there.
So, on the necessity, kind of going to that, you were talking about, can we imagine a universe half the size?
Yes.
And couldn't that also be the possibility? I mean,
Yes.
because
So
within a specific realm, it doesn't necessarily have to be this universe with all the exact data that we have. Could
yeah, that's a good
like-
point. Let me make a clarification because I should have said it this way. This number up here, the 1 over 10 to the 10 to the 123rd, 1, and 10 to the 10 to the 123rd. What does this number right here represent? This number does not represent a single universe. This number right here represents a range of universes of a certain width on here. And the ratio of this width to the entire width is 1 over 10 to the 10 to the 123rd. So it's not a single instance of the universe. It's a range of universes that would have the properties that allow basically a universe that's something like 14 billion years old that sits kind of on the knife edge as ours does in terms of expansion and size and matter content and the organization of that matter that allow that to even be instantiated in the first place.
So maybe I'm not getting it, but couldn't it necessarily have to exist within those certain parameters? Otherwise, it's not a universe.
If it okay, so you're trying to say that the range is necessary, not the instance itself.
Kind of like, I guess, like humans, like one born with 3 arms is still a universe.
Yes.
I mean, it's still a human. One born with 1 arm is still a human.
So what you're actually saying is something like this. Okay, so they're saying, I'm going to go back to the bookshelf. Do you like the bookshelf? Is that okay enough?
Sure.
Okay, I'm going to go to the bookshelf and I'm going to say, okay, in order for the universe that we see to be there, you've got to have something like 4 shelves And all the books have to be on the shelf initially. Like if one of the books is falling off the shelf, this universe doesn't work. Okay? So it turns out that there's some space in the shelf, right? You can fit a couple of other books in there. Let's say you could fit 5 more books in this shelf, and you could fit 6 more books in this shelf. Okay, so you can all right, that still counts as part of the one. What doesn't count as part of the one is one where the book's laying on the floor. Okay, any universe where the books are laying on the floor is outside of that organization of universes in there. And what they're saying is the range of possibilities, given that this shelf right here can only contain, let's say, a max 50 books. So there are some number of configurations, a lot of them, right? There could be 1 on one shelf, 2 on the other shelf, 3 on the bottom shelf, or et cetera. So this range of 50 may give you some big number of, 10 to the, we'll call it, we'll just say 10 to the 7th possible configurations of this shelf that are still permit a universe like ours. Now that 10 to the 7th is like against this number. Like even if you don't take the 10 to the 7th out, right? Ignore the 7th. When you compare it to this number, it's nothing. It's still basically 1. So even if you wanted to, for fun, just basically be like, okay, because it's 10 to the 7th possibilities, and this number already contains this, right? The 10 to the 123rd already contains what I'm about to show you. But okay, just for argument, I'll knock it way down. I'll just make it 10 to the 10 to the 122nd. You're still so far out of whack that this ain't happening by chance. Now, so the question is, do these configurations, your question is about necessity. So do these configurations have to exist? Does it have to be the case that all the books have to be on the shelf? No, right? We can conceive of them not being on the shelf. In order to say, like, let's draw our line here. Here are all the different ways that the universe could be, the initial entropy condition. Here's how that universe could have been configured initially at the kickoff point. And what we said is, I'm going to blow this up, but there's this tiny little range right here that wouldn't even be that big. When you make it big over here, here's our line, and it's this range right here. That there's this tiny little range. You're asking, I guess I'd ask you this question. Why do you think that this part of this whole line right here is necessarily the case? Why do you not think that this could possibly be true? Or this over here?
It could, but then I don't think it would be a universe. Just like someone born, well, like if a woman gave birth and it was just a foot, we wouldn't say that was a human. We'd say it was just a foot. So to necessarily be a human, it has to have all of those things.
Sure, but in this case, human would be analogous to life-permitting universe, and foot would be analogous to universe. That's what this argument is saying.
Wouldn't foot just be like the gravitational constant is some far out number that wouldn't support the universe?
Well, in this case, we're not talking about gravitational constant. We're just talking about initial entropy condition. So in just talking about initial entropy condition, what we're saying is, given that there's a universe, period, so that you already got a universe, that's a done deal. Now, how organized is that universe at its initial state? So it could be organized this way, or it could be organized that way, or it could be organized this way. Of the this, there's one of those. Of the that way, and all the other ways, there's 10 to the 10 to the 123rd of those.
But that's going into chance.
Yes, that's speaking directly. It's because it's saying that's all the possibilities out there. It's saying how could the universe have been organized? Here are the cards. This one is organizational state. Everything's in a big cube. Everything starts in a big cube. This one is the organizational state. Things start in a perfect sphere with a certain density. And this one's an organizational state where it's slightly oblate, or something like that. That this organization of everything that matters, all the physical reality is contained in that part. And so what we're saying is there are 10 to the 123rd cards of how that could be. If you're asking the question of necessity, what you're saying is, remember this is about what it goes to how it all ends, but it's only talking about the initial entropy condition, what's its state of organization, low entropy, highly organized. What we're saying is it is a universe, period. How organized, in what way is that universe organized? That's all we're asking.
Right.
Does that make more sense?
Yeah.
Okay.
I think you might have said this in your 4-week class, but is there some scientifically accepted probability that could occur. So for instance, in particle physics, CERN, Fermilab, when we're trying to identify a new particle, they have something like a
Six Sigma.
Six Sigma, yeah.
Right.
This is, if it's within this probability, then we can say that it's scientifically plausible to move forward with.
The easiest answer to this question that I would say shows that even the opposition recognizes that whatever that probability bound is where we want to start proving stuff, and that's for proof for a particular reason, given the test mechanisms that they have. But ultimately, what the existence of the multiverse at all is proof positive that cosmologists recognize this problem as not overcomable through chance. Because if it was overcomable through chance, if it was simply a matter of like, no, it's more like this Six Sigma type of measure when we're looking for particular interactions at the Atlas sensor of CERN or something like that, then you wouldn't need a multiverse. An infinite multiverse only exists to give you the probabilistic resources to bring chance back into the equation.
Yeah, because I remember the 90s when, before they realized that the universe was expanding, they thought it was contracting, and the idea was, your idea, so it's a universe, it doesn't meet all the criteria, it springs in and it collapses, and it comes in and collapses. So then it was infinite amount of time, infinite retries, and eventually they got one that just kind of worked. Well, then that doesn't match the way the universe is going. So that sort of fell away, and then I think that the whole multiverse became out of that more popular.
Yeah, that fell apart because bounding universe theory, it keeps coming back. Bounding universe theory keeps coming back. The problem is this little neck that you're going through, it exists at this high state of organization. So your crunching universe here that is retracting back down into this thing that's going to serve as the thing that expands to create our universe, our highly improbable universe. It's analogous to like a universe where by random chance books build themselves and then they jump up onto the shelf and they're really organized, and then the shelves organize into these great warehouses, and these warehouses are organized themselves into this nice grid layout where that kind of, that's a man-centric idea, but if you could take that into the physical world, that's what's having to happen. What they realized was when you try to do that, you end up with the exact same probability problem that you started with. It doesn't make it any more probable. You still have to solve the same probability problem. And what they realize is if you're off by a biscuit in any of those efforts, you get these black holes and singularities that form that just tear everything apart. And so even if it starts some rotational universe, not any rotational universe will stabilize at some condition that doesn't, that allows it to achieve this kind of very, very high, low entropy condition initially. So this neck right here is the problem. No matter how many times you do it before, no matter how big or small it was beforehand, you still have exactly the same probability problem. It doesn't buy anything. It doesn't do anything for you from probabilistic resources.
But is that the case, right? Like we're talking about like all these like highly tuned conditions that had to be set in a very like finite point in time at a very tiny level. And we're saying, like, let's just entertain the idea that we're going towards a collapsing universe, and it's going to bound back to that. We're saying that to come back to that neck, it resets it every time, and there's no chance that it could be tweaked just a little bit, or one quantum particle could be out of place that could then, you know what I mean?
What I'm saying is, if one quantum particle is out of place, not one, but if some number of them are out of place, you don't get this. I'm saying it's almost impossible.
Right, that's my point. Like,
no, that's what I was saying. If I didn't say it right, what I'm saying is this universe right here also has to be organized in such a way that its entropy condition will be higher. Okay, so it's in some high entropy condition. But the way that the work, typically speaking, when we try to go from high entropy to low entropy, work has to be done. Not necessarily work by humans, but some sort of work has to occur to happen. The entropy condition, whatever this entropy condition is, plus the work that has to be done, have to be so perfectly matched that they exceed this number as to their perfection. So it doesn't make the problem easier, it makes it harder.
So, because in my mind, I'm like, we'll just burn it all down and everything explodes.
Right? It doesn't work that way. Okay. You've got to burn it all down in such a way that the fire builds you a fleet of jet aircraft that then start to do the work of building you the other stuff.
You keep referring to initial conditions.
Yes.
Are you talking about the initial conditions at the Big Bang?
Yes, whether it's a singularity or not.
Okay, but
So for non-singularity theories, this still holds.
there was a period of, I hate to call it time, but there was a period before the Big Bang, the epoch time. We have no idea what that was.
So there's, in standard Big Bang cosmology, there's no period of time before the Big Bang.
Well, there's a period, there's something before the Big Bang.
There's a singularity.
Well, it's a theory that could be a singularity.
Yeah, that's Big Bang theory. So here's the singularity, here's the next point in time, here's the next point in time, here's the next point in time, here's the next point in time. Like, there's nothing like Big Bang is talking about from this point forwards. So it's not like there was this thing and then there was a Big Bang. That's just not Big Bang theory. Big Bang theory talks about the expansion of the universe from a singularity. That includes the singularity. So this is the point at which it starts expanding. Now there are non-singularity theories of time, of the universe, of cosmology. They have the same low entropy condition problem.
What is the Planck epoch?
Planck epoch is the shortest amount of time that we believe that we can ever possibly measure.
And that was before the Big Bang.
No, the Planck epoch is the amount of time that it goes from the singularity forward in time, 10 to the negative, what's the Planck length?
I have tables for all
Yeah,
this.
yeah. So let's call it 10 to the negative 50th. I don't know what the number is. Okay, 10 to the negative 34 seconds. So from 0 to 10 to the negative 34 is a period of time. It's called the Planck epoch. An epoch is a measure of time.
But the Big Bang didn't happen until after that.
No, the Big Bang happened from 0 through the Planck epoch to the end of the Planck epoch. Again, you're just wrong. You have to look that up.
You could be.
I could be wrong, but I will bet you the $50 that I didn't want to wager on my 1 to 20, 52 chance that the Planck epoch happens in time.
That's correct.
Okay, good deal. Yes, ma'am.
I get that this universe is improbable, but isn't the fine-tuning kind of argument that it's the only one that could support life, therefore it's the only one where we can marvel at how lucky we are that we won the lottery? Like all the other ones substantiate universes that no one can observe.
That's right.
So, I mean...
So that's not right. The most probable universes out there that support observers are universes that are very, very small. Not very, very small, comparatively speaking. Let's say they're small universes. The size of our galaxy or smaller. Where what happens is, because of some other low entropy state, which by the way is way, way, way higher than our own, or the one that we're in now. But in a less low entropy state, you kick this thing off, and a single brain, like BRAIN, a single brain, fluctuates into existence for 10 seconds before it comes apart. Those kind of universes are insanely more probable to happen than our universe is on these kinds of fine-tuning, constants and quantities. So and by the way, those universes are still part of that oil spot I was talking about. That tiny little oil spot, most of that's on the big cube of water. So that tiny, tiny little oil spot in here, if I blew that up and said, here's that little leaf-sized oil spot, and I'll actually make it somewhat leaf-shaped. Here's our stem, there's the leaf. Yeah, see, okay. Yay. Here's us, we're a little dot on that leaf. Most of this leaf, for observable universes, actually let's say that this is the observable size of it, where observers would come to be. Those kinds of universes, there are billions and billions of those compared to our own. So if we are going to say, well, we're going to adopt some sort of anthropic principle that says we see it because we're here to see it. Well, if you're going to do that one, what you should say is, well, I still don't see a universe where I just popped into existence and winked out of existence. I'm here for a long period of time. I'm here for, because you don't observe that, you observe yourself to be in this universe, it's highly improbable that any other kind of universe exists.
How would we even look for those universes? I mean...
You wouldn't. What you're doing here is saying, I've been dealt a card. What card have I been dealt? Okay, so there are 52 cards out there. 52 of the cards, now let's say there are 10,000 cards out there. This is because this will be closer to the number than 52 will be. There are 10,000 cards out there. I picked one at random. Having picked one at random, what I ought to see is I existed for 10 seconds or 5 minutes or 10 minutes or something like that. That's what I ought to see. All right, because there are lots of those, but there's only one like this, or not one in this thing. There's only one like this. All right, so I drew this card and I got one like this. So I just picked at 1 to 10,000 against this one. Did that happen by chance, or is there potentially another explanation? So now, in order to even make this meaningful in any way, we have to establish some sort of probability for design. Our intuition is design. So let me make the quick design portion. Oh, I can't. We'll do this next time. All right, we're out of time. We got 4 minutes. I'll make this part, and then we'll expand on it next time. Remember what we agreed to do in terms of epistemology. How do I know what I know? What we said was, I come to the table with a bunch of thoughts and beliefs and intuitions. I'm reasonable to treat my intuitions as true until I find a defeater for them. And that doesn't mean that everything I think first is true. I think the sun looks like it goes over the earth. All right, that's reasonable to think. Then I come up with other evidence. Some guy's like, I stuck this stick in the sand and the following things happened. And someone was like, I went to space. Here's a picture, and you see the picture from space and you want to say, all right, now this we go around the sun thing makes a lot more sense. And then you see it explains a lot of other stuff. And then you say, all right, maybe we are on a ball and maybe we do go around the sun. Our intuition told us didn't say that was it, but we learned it through a series of defeaters that got us. Okay, so now, but you start with your intuition. The intuition is things don't happen with these highly improbable events don't happen frequently. What happens frequently are probable events with greater frequency than improbable events. That's basically what probability means. And so when we do the math on it and we realize that these are insanely improbable, what we ought to say is that it's also insane to believe them unless we have a defeater for why that would be the case. Now, if we come up with some evidence that there is an infinite multiverse, we actually had evidence that there was an infinite multiverse, this argument can go away. But we just don't have any evidence for that. And so if someone turns around and says, well, you don't have any evidence for God either, you turn around and say, no, I've got a cosmological argument that makes it the case. I've got a contingency argument that says I got reasons to believe this is the case. I have an intuition that seems to be shared by 7 out of 8 people or more on the planet. I've got all of this. These are not only is it my properly basic belief that something like a God exists, I've got these other arguments that suggest that there is a God. So, and not only that it seems to be highly probable that there's a God. And now if I turn around and plug that into this equation, even if you end up this argument, even if you end up with having looked at the cosmological argument and the contingency argument, and you're like, well, I don't want to be hasty, I'm still going to say there's a 1 in a billion chance that there's a God. All right, so my designer argument that a designer could even exist, a God-like designer could even exist, there's a 1 in a billion chance that that's the case. Fine. Do you know how much better that is than the chance option? Orders and orders and orders and orders of magnitude that we can't even comprehend. That's how much more probable it is. It's simply irrational to believe that, based on arguments like this, that God doesn't exist. The most rational position is that God exists. In fact, you have to ignore the defeaters for your view that God does not exist in order to continue to believe this. And that's the point that I'm getting after here in total. We'll talk about the combinations of all these arguments so far next time. And thankfully, looks like we might finish this one for this year so we can kick off maybe some of the more interesting interreligion discussions coming up here in the end of the winter and springtime. So I think that'll be fun. Does anybody want to go? I know this was probably way too sciencey and physicsy for some folks. Is this still okay? Did this scratch your itch? Are we okay with the design argument for now? All right, enough of that nonsense. We're going to the right. All right, next time we'll get into putting all this together. And in the meantime, does anybody not want to meet next week? Is anybody not going to be here next week? Other than people who aren't going to be here next week. Okay, all right. We'll meet again next week then, and I'll see you guys next time. Merry Christmas, Happy Hanukkah. When does Hanukkah range this year? Starts tonight. Happy Hanukkah.
New Jersey. My wife's dead. Meeting to have this conversation.
No.